Hello listeners, welcome to a brand new episode of RawBotics. Today we bring to you Carnegie Mellon alumnus who after graduating, straight away jumped into the chaos of Wall Street and learned his ropes at BlackRock, eventually becoming an important pillar of the American multinational investment company. His love for robotics eventually drove him back to India to start Niqo Robotics, giving up his American dream in the process to launch India's first AI spot spinning robot in 2023. Please welcome Mr. Jaisimha Rao on Robotics.
Hi, everybody.
So Jay, investment banking, robotics, agriculture, Carnegie Mellon, these are all very discrete things. Could you share with our listeners how did you traverse this journey?
Yeah, I think in that list, probably Carnegie Mellon Robotics have the closest overlap. I went to Carnegie Mellon at a very interesting time. And this was 2003 to 7. There was this challenge called the DARPA challenge, which was funded by the American government. How do you build an autonomous robot? And Carnegie Mellon was the leader in that. So I got bitten by the robotics development work that was happening at CMU. But unfortunately, in 2007, instead of chasing technical wisdom, technical ambition, I chose money and I landed up in Wall Street. So
Wall Street was the thing at that time.
2007, like all the smartest kids went to Wall Street. But there's a big asterisk because I think the kids who were smarter than us became Facebook employee number 10 and 12. So yeah, I think 2007 was like the peak of the American economy. Wall Street was a good place, at least engineers like us, to show off quantitative skills. So I was one of them. I jumped right in. BlackRock Financial was an interesting company to work with. It was very strict. So I clearly remember that, we had to show up to work at 6:30 in the morning.
6:30?
Yeah. And you show up at 6:31, it's considered late. And every Friday they have name and shame. So during the week, whoever came beyond 6:30, they put it up on the big board and said, you guys came in late. So I think when you're 21, you need that discipline. The irony is, I struggled to get people in at 10 o'clock here in Bangalore, which just makes me crazy. But sometimes you have to shift your requirements as you shift industry. So yeah, I just went with the flow. I got my computer engineering degree at CMU, got this good job. 2008 happened, the financial crisis blew up. And because of that, BlackRock got additional business. So this was in like a group where the more chaotic it was, the more business we got to advise people how to manage the chaos. So I stuck around for 6.5 years. And then in 2014, I saw my boss and I saw the life that the boss is leading, which is you eventually move to Connecticut, you take the train, you vacation in the Bahamas, and that's what life is. So I think that freaked me out. The predictability of what is a career, where I'll be when I'm 30, 40, 50, 60. That is one. And I didn't want to do that. So I had my 7 years at BlackRock. I had a bunch of savings during that 7 years. And I decided to roll the dice and come back to India. At that time also, by the way, this Shah Rukh Khan movie, Satish, was launched.
So that inspired you?
Of course. Like, how can you not get inspired?
Very true.
You leave and you want to come back to India and everything in India is, a nation is rising, so you want to be a part of that. So, and I still believe that. So that was purely an emotional decision. It's a wild idea, but moved to India. And I think why farming? Us as a family, we have a 20-acre farm. It's about 5 hours from the place we are recording now. And that's when I realized that farming generally is very wisdom-driven. So how do you make farming more precise, scientific? I think that was the inspiration of combining my technical, probably 4 years at CMU, and finding a use case to that.
Very true. Farming has a lot of native intelligence involved in it.
Yeah.
Definitely.
Yeah, I mean, this place of wisdom, we're not discounting that, but
yeah,
it can't be 100% wisdom. That's
true. So can you tell us something about how, eventually Niqo Robotics started, you froze all farming, you decided you want to do something here and make some use case. So how did the entire Niqo Robotics journey came about? How did you move forward in this?
Yeah, are you ready for a roller coaster? Because you got to strap in, because it's not been a straightforward line for us.
And I think this was a time when robotics was not the thing or very glamorous.
Is it a thing now? We still
Definitely better than what it was a decade back.
yeah. Definitely much better. But yeah, I think it's 2015. I started the company. Interesting enough, I was allergic to venture capital. I said I can do this by myself. I bootstrapped it from 2015 to 2019, and we started off as a drone company. So how do you find drones? How do you fly drones over farmland and add value? So we provide analytics. And over the 4-year period, what we realized is farmers, especially the farming community, doesn't like analytics, doesn't like advice. They want a solution. So the use case of the drones, you fly over farmland, you would figure out where the plants are and tell exactly what is your population count. The farmers told us, hey, once you know what the population count is, come and fix it wherever there's domination. And that the drones cannot do. So it was a painful 4-year product market fit journey on trying to sell kind of advisory as a service to the farming community. And that didn't work out. So that's when I also personally ran out of my bandwidth. And that's when we realized we need to combine our analytics with a piece of hardware to deliver a solution just on advice. So that's when we got down to land-based robots that combines with our analytics that we developed over 4 years. And then from 2019 to now, I think we have a few products that we have developed specifically for farming. And I think the Eureka moment happened last year. So just for folks who are listening here, I started 2015 and the Eureka moment happened 2023. So
8 long years.
Yeah, and you're just chasing. And during that journey, you will get a lot of people who say, oh yeah, drones are amazing, it's the future, robots are amazing, it's the future. You'll ask the customer, is this what you want? They'll say, yes, you build that. And they'll say, yeah, but I'm not going to pay for it. So I think you'll have to navigate all these signals from the market, what to build. And it took us, shouldn't have taken us 8 years, but it took us 8 years. But last year, our precision spraying robot, we've shipped 50 of them across India, and
that's amazing.
Thanks, I think that's a big number. I think globally also, when it comes to precision spraying technology in agriculture, we're probably right on top when it comes to the scale. But I think the most satisfying part is when we actually saw the tech in action, and the farmers saw that they could reduce 50% of the pesticide, and they opened the tank, and they saw there's 50% of pesticide and water left. And for that, the farmer is real money. So that was the Eureka moment. It took us only 8 years.
But it definitely happened. That's a positive.
Yeah. So I think that's something that we are proud of.
That's great. So you said that your robot helps in precision spraying and that saves a lot of pesticide for farmers.
Yeah.
So how does technology enable this? How does the robot exactly do this? If you could take our listeners to this.
Yeah, currently if you're a farmer, you have 4 acres and you're going to have a sprayer that sprays your entire field, what we call in blanket spraying. So irrespective of whether there's a plant or not, whether there's soil or not, then all the nozzles of the sprayer are on all the time, which is silly because the energy that you'll now is if you're a class teacher, you have 20 kids in your class, 3 of your kids are sick, you're not going to give your entire class pesticides or medicine. In farming, we're doing exactly that. So where's the technology play? Our technology puts a smart camera on a sprayer. So we retrofit existing equipment. And if you take a very easy example of pesticide spraying, we are spraying pesticide only on the plant and not on the soil. So if you specifically, again, pick cotton, there's almost 4 feet of gap between 2 rows of cotton and 2 feet of gap between 2 cotton plants.
Okay.
So our technology sprays exactly on the foliage of the plant and doesn't spray between the plants or between the rows. So to a farmer, if you just take AI-assisted spraying with blanket spraying, there's a immediate 60% reduction in pesticide and water. And there are other consequences as well, because now you need less diesel on your sprayer, you can spray more acres per day. But that's what our technology does. So to answer your question, it is AI, computer vision on the edge, We had to train on what a cotton plant looks like at 6 in the morning. It looks very different at noon. At 5 p.m. it's drooping. So the soil looks different in Akola, Maharashtra versus Telangana. So getting the data set right, making sure you spray on every plant. I think those are all the technical hurdles that we've been able to cross.
There are really challenges in terms of hardware because agriculture landscape would be very different across the country.
Yeah. I think in agriculture, most of the equipment is made for abuse. And as long as you're dealing with machinery, iron, steel, I think those kind of materials can take abuse. But as soon as you get into our world, now suddenly you have a NVIDIA processor, you have PCBs, you have a camera with a lens. So heat, dirt, dust, some dings, I think, here and there. I think we get to this when we speak about this. But the need for excellent mechanical protection is probably a big blocker in robotics. Because in general, if you're trying to combine, say, computer vision, that'll work. But how does it work in the real environment? You need a good foundation. So that's been a big technical challenge that we've been able to overcome.
That's great. So you said that you've already deployed robots in India. Do you also see a global market for your spraying robot as well?
Yeah, the wonderful thing about agriculture is every place in the world requires food. And to make food, there's probably some pocket of agriculture in every country. So if there's a global play in what we are doing, there's always an opportunity to move agriculture pesticide spraying from a blanket spray to precision spray. And we are keenly looking at expanding globally this year. So we're excited about that. I think India, we do have home court advantage. There's 120 million hectares of agriculture in India. So the scale of India, no country can match at all. So we do need to leverage what we have going for us in India. The margins are a little bit tighter, but we do have to play the long game here. But maybe opportunistically global is the way to go short.
Very true. So since you mentioned that you've deployed the robots, there is something that I am very interested to know. So a farmer typically might not be very aware about the robot since you're talking 4 acres is the average holding.
Yeah.
So how does the farmer interact with the robot? How does that interaction happen? What is the kind of interface that you've given?
Yeah, I think specifically for agriculture, if you look at it, it's a very peak and trough cycle. So all farming in Kharif season happens within a few hundred days. And the rest of the season, you're not doing much. So we didn't want to put the burden of technical adoption on the farmer.
Okay.
So the 50 robots that we've launched this last season and we continue to operate it's a farming as a service. It's a robot as a service. So we have trained technicians who are interfacing with the display on the sprayer. They are selecting on a screen which deep learning model. Is it a cotton deep learning model? Is it a chili deep learning model? Then there are a few variables there you can play with. When does spray start before the plant? When does it stop after the plant? So that interface, the operator of the sprayer does.
Okay.
So he in turn is the key man for adoption. The farmer himself or herself is just engaging the robot as a service. So they engage us and say, I have 4 acres, can you come and do precision spraying on us? So if you ask me, the operator, you won't believe, given the experience with operating smartphones, in some cases, they're better at navigating the screen, selecting the model, selecting the specs better than our own stuff because they've done it more. I think that's another important piece to robotics. Like, how do you make it super easy to use so that anybody could use a smartphone can? So that's been our go-to-market for India. And I don't think we've had any technical issues in terms of folks not understanding. The second part of the question, I also say, robotics is a scary name because when you say robotics, people think all kinds of things. In your case, it's warehouse robots that are moving in a factory and trying to move things. In our case, if you're going if you're going on the road and you're seeing the sprayer spray, you won't notice anything different. So is the ability to turn nozzles on and off. But to get that at a very precise level, you need the ability to see, the ability to process, and then finally the ability to act. So the farmer, as soon as they see a sprayer turn on and off and spray only on the plant, they're sold. So we usually do a couple of lines pro bono just to show that it works. I think most of the time when they see it spray only at the plant, they say pura kar do. So they don't need to know, are we using YOLO-D model or NVIDIA Jetson? We don't need to complicate that. You're spraying on my plant, you're not missing any plant. Now go ahead and do it. So
What would be the frequency of this spraying typically in a growing cycle?
there's about 7 sprays in a full cotton season. So it's it's quite sticky when it comes to how you're interacting with the farms.
Since you mentioned that, when we deploy robots in warehouse, we have a very good infrastructure in terms of connectivity and internet, right? So since you mentioned you're using Edge, how did you solve this problem of connectivity or data? Did 5G help you in some way, or what is your experience around this?
I think for us, connectivity, we assume that there's going to be zero connectivity. So it's not only India. In fact, maybe India is probably better connected rurally than other parts of the world. So more than connectivity, our technical challenge in outdoor robotics is you'll never know which farm you go to. Every farm is different undulations, different curves.
There will be no North Star per se.
There's nothing to say that this is 0-0.
Yeah, correct.
So the real technical challenge that we have been at it is how do you make sure with different AI techniques, localization, SLAM, how do you make sure when the robot moves on a millimeter or centimeter level, that reading is as pure as it gets without noise? So that I would say is more of a core challenge than connectivity. And we are super generous of you because in warehouse robotics, all the techniques, all the literature out there is localization of the robot in my warehouse, in an indoor environment.
Very true.
And my robotics engineers don't have that luxury. So we'll be in Apollo one day, we'll be in Punjab the other day, and we still need centimeter level precision.
But you have been able to solve it to a large extent.
Yes, we have. I think that's when people think about robotics and generally the AI wave that we are currently on, if you start peeling the onion, the core of what makes a good robot is probably not AI.
Yeah.
It's these different, deeply technical inventions that you need to implement, like odometry, localization, thinking out optimization on your processor. But as hungry entrepreneurs, we will bundle that up all into AI and sell that. But since your audience is probably more robotics focused, that's where the real action is for us.
True. Very true. Since there is a lot of focus on green sustainability, we've been hearing a lot about climate farming. So if you could talk to our listeners about climate farming and how does your robot fit into the bigger scheme of climate farming?
Yeah, if you pick one of our farmer testimonials, before our technology, the farmer was spraying about 200 liters of mix of pesticide and water. As soon as they used our CN spray technology, spot spraying technology, that 200 liters dropped down to 100 liters. 50% savings direct. So with this number, and again, there are certain farmers who have experienced 58%, but just for the sake of argument, let's assume a clean 50%. If we do a 50% savings, and if you're saving 100 liters of water on one spray, and multiply that across 33 million acres, just imagine the amount of excess pesticide and water and diesel that is currently being used for complete waste. I mean, this is not adding to the productivity, it's just going into the soil, it's contaminating the water.
Now it's probably having a lot of damage, in fact.
Yeah, so if you start looking at agriculture, the areas where we can make a positive difference, this is the no-brainer invention. Where 200 liters versus 100 liters. There is no effect on output. So why aren't we doing that? So that is what we are excited about. It's easy for us to sell it to the farmer. The farmer sees it. It's easy to understand, and also going on and on. So 33 million acres, 100 liters. This is not a climate story. I'm not sure what is.
That's talk about impact, and that's really it.
Yeah.
Very true.
Yeah.
So you mentioned you got to work on DAPA projects when you were in CMU.
I was a bystander. I didn't work on it, but yeah,
Okay.
I did see it.
Yeah, you did see it, and I'm sure you would have seen a lot of things at Carnegie Mellon as well.
Yeah.
So beyond agriculture, right? So what are other robotic applications or robots that have captured your imagination? I'm asking you this question because since you've almost been at the land where a lot of things were happening in US.
I think autonomous driving is something that gives you goosebumps. We were in California a few months back, and we borrowed my brother-in-law's Tesla, and we just put into autonomous mode. And for a first-time user experience, to see a car change lanes, accelerate, decelerate, exit a road, I think the future is here. And you can imagine a fleet of those autonomous cars doing dropping off your kids, doing chores. So I think I've experienced it, so I'm excited about it. Now, will we get to see that at scale? I think the last 5% is going to kill the tech.
Okay.
But because we'll always be in this moral dilemma of what if an autonomous car crashes versus a human car?
We're seeing this playing out.
Yeah, we're seeing it in real life. But I think that's like a goosebump moment, one. Number two, something closer to what we are doing. In agriculture, again, it's just to set context. If you look at a farmer's life, the farmer buys whatever he or she needs to do for the season upfront. So they'll buy seeds, they'll prepare their land with the tractor, they will buy pesticide, and they're buying all that detail first. So they do all this effort, 180 days. I dig the soil, I put the seeds, I spray, I nurture it. And finally, when it comes to harvest, literally you have money on your farm. Whether it's cotton, whether it's fruits, vegetables. Now, that peak demand, essentially you suddenly find yourself in farming, there's a 3-day window where all of India, so all of Maharashtra needs to take the cotton off the cotton.
So,
And we don't have enough people to do that. So you get in early situations where only for harvest, the prices peak like 3x, 4x. And the irony is, once the harvest is done, the farmer sells at a wholesale price. He's buying at retail, selling at wholesale. And when he sees money on the farm, he's at the mercy of market demand. So if I had unlimited resources and if I had a relatively long kind of 10-year plan, I would definitely try, I think, picking robots for agriculture is another area that I think there's a big need for it. And it's solvable. And it's a huge problem. And the irony is we have 1.4 billion people, and I'm saying there's a labor problem in India. It's people can't digest. Imagine other countries. And that's number two. Number three is something similar to what you guys do. I think I've been to a couple of warehouse robotics, fully automated. I think it's very, very gratifying to see small machines talk to each other and coordinate with each other.
yeah, this is what we call robotic symphony.
Yeah, that's a good way to put it. So I think it's cleaner, it's safer, it's more optimized. So I think warehouse robotics, we need more of it. And I think the warehouse of dealing with so many packages is quite dangerous, error-prone, very costly. So I think Addverb and the work you're doing is, I think you should do demo days. You should bring people to see one of your automated machines.
For sure. We have now put up a manufacturing facility in Greater Noida, which is one of the largest, where we have all these robots and automation systems at play for customers, where they can come and experience how the robotic symphony plays out. So just to end it on a lighter note, if you had the ability to become a robot for a day, what would you like to do?
It's always a childhood dream of mine to become a fast bowler.
Oh,
So, I don't know.
so while walking, do you still act?
Yeah, now it's shifted to golf. But
Okay.
But yeah, I mean, if you see me in an elevator here when the door closes, I'm practicing my swing. Yeah, by myself. But that's all we all do. But maybe it's like one of those things where, we used to get up early in the morning, watch India tour Australia, and see all these fast bowlers. if I can have a retrofit kit on me and make my 38-year-old body bowl at 160 kilometers per hour, like very personal, shallow goals.
You can probably have an exoskeleton. We can help you with one.
Ah, really? You got to make my dream come true.
Yeah, we have an exoskeleton.
Okay. Hook it up to me and then I can show it in front of my family that I can bowl at 160. Because I don't think I ever crossed 90 kilometers per hour. So I think that will be one shallow boyo dream that a robot will help me accomplish. Yeah.
That's an ambition that should definitely be fulfilled.
I'm sure the other important problems to figure out in this world, but yeah, I think this is something personal for me.
Thank you, Jed, for a very enlightening conversation. Thank you for your time.
No, thanks for having this. I think we don't get our fair share of limelight, the work you're doing and work we are doing, mainly because it does take time. The gestation period is so high. By the time you figure out the tech stack and go to market, the world has changed.
Yeah.
But I feel like the next 10 years is probably deep tech, combining software with hardware, and we're going to have multiple successes here. So I think our time is coming. That's the feel I'm getting. I don't know about you.
Yeah, for sure. Thank you. So listeners, I hope you enjoyed this episode as much as I did. Like and subscribe to continue on this robotic journey with us. Until next time, this is your host Satish Shukla signing off.